The LVS code. Actually, I should Control Shift B. Right now, nah. I wanna make love right now, nah. Terminal. Run build task. Control Shift B. Activating extensions. Development build. Kitty cat. Off my lap. Kitty cat. Off my lap. Alright. Yes. Kitty cat on my lap. Kitty cat is on my lap. What you doing on my lap? Kitty cat on my lap. Hey, kitty cat. Oh, and use pin no longer exists. Node release. Come on. Delayed. What's the warning? Component classes not set for grabber. I'm gonna add this. Why does this keep happening? Grabber. Delete. Grabber's right here. Grabber.cpp. Right here. I can see it. Can we live code this? Control S. Live code. Is now a good time to maybe duck over there and just put some stuff in the microwave and make some food? I think it is. I think it is a good time. Live coding succeeded. Data type changes may cause packaging to fail. Updating product SDK. I want to add grabber. Yeah, baby. Grabber can go first print. Hey, that's a Kitten Chrissy. What up? This is release. And this is grab. Okay, cool. And then I think if we... Very annoying that it doesn't save. Like, very annoying. Kitten Chrissy. Sauce that follow back. You a real one. You a real one. Homie. Oh, that's another follow. Let's go. Who was it? Dream Blue. We'll toss that follow back, baby. Appreciate it. Helping me grow my channel. Keep it up. Let's go then. I am not. I am trying to learn how to build games. So I'm following a Udemy tutorial that I paid for online. So right now I'm just learning how to like pick up objects. So this thing, did it code? Did we succeed? No, we did not succeed yet. So once this thing kind of, so I've got like a pretty not great computer, so I have to like shut everything down just to run Unreal Engine. Uh-oh, there we go, link patched. All right, let's see. This should work. Famous last words. Come over here. Oh, I picked it up. Isn't that great? Hell yeah. All right. So I got to go back. I basically just got to where I left off last time. So I'm following. I've got 44% of this tutorial complete. I'm just going to continue to follow along with it.
The tool. So I'm just going to remove
Oh, where am I? Grabbing with
that code there. But what I am going to do is I'm going to add a log message. So we're going to create a variable to store our result here, because if we return and then try to print a log message, that's not going to work. So we're going to have a uphysics handle component called result. That's what we're going to return out of here. And we'll say if the result is equal to null pointer, well, then we need to ulog with a warning, or in fact an error really.
How's your day
and
going?
We're going to say grabber requires a uphysics handle component. And then after the if statement, so this will happen whether or not it is null, we're going to return the result. So let's go ahead and compile that and check it all works. Seems to have succeeded, and I can see it must be working because when I left click in the scene, I'm getting the blue or debug orbs being drawn, and they wouldn't be drawn if we weren't getting hold of that physics handle component. Great stuff. So in this lecture, we've been able to grab our gargoyle statue using our grabber, albeit sometimes it can be a little bit unreliable, and we're going to sort this out in upcoming lectures. So I will see you there.
Upcoming lectures. Waking physics objects. Whatever that means. Oh, I think that means
Hello,
like
welcome. In this lecture, we're going to be making the grabber much more reliable, and also we are going to be making it possible to drop a grabbed component so we can throw it around and generally have it be a little bit more useful. Let's dive in and see how this is done. Now, the reason we're often not able to pick up this gargoyle is that components that are simulating physics for performance sake will go to sleep when they have been still for a certain amount of time. And that's what we're seeing. This gargoyle's physics simulation is going to sleep, and it's not being woken up when we attach to it with our physics handle. So what we need to learn to do is to wake it up when we hit it with a sphere trace. Now let's go and have a look at the U primitive component documentation. We've seen that the U primitive component is the thing returned by our hit result, but what actually is a primitive component? So it says it here in the documentation that a primitive component is a scene component that contains or generates some sort of geometry and is rendered or used as collision data. So generally speaking, primitive components are ones that can simulate physics. So we can expect to find some physics simulation methods on here. And what I'm going to look for is a function with the keyword wake in it. We're going to look through a few functions until we find one that says wake all rigid bodies.
Wake all
Rigid bodies are essentially a physics term for objects that simulate physics. So you can see it has a void return type, doesn't take any arguments. So we should be able to just call this when we are trying to attach to it. So if we go to our grabber CPP, inside our if statement, we've hit this component, we're about to grab it. The first thing we need to do is maybe let's make a variable to store this U primitive component. So we'll have a U primitive component.
I don't have enough room on my desk here. U primitive component.
Pointer called hit component. Set that equal to the hit result dot get component. And then using that hit component pointer, we can arrow wake all rigid bodies and then put the parentheses and a semicolon at the end. So this should just give that component a kick.
I don't really understand what this is doing.
Wake it up so that it responds to the physics handle. Now let's replace where we've done hit result.get component in our physics handle call to grab component location, because we've now got a variable for that, and let's recompile. When that's done, let's
wait. Yo. Can you not do that? Hit component.
because we've now got a variable for that, and let's recompile.
Let's recompile, shall we? See if I did it right. God damn it. Building takes forever. Got a little food. Not in a bad spot. I forgot to change my games. I'm no longer playing Apex Legends. I'm playing game development. Playing game development. Game development. Save. All right, cool.
When that's done, let's go ahead and hit play and let the gargoyle sit a little bit on the floor for now and let it go to sleep. And then try picking it up. And you'll notice that we've got no problems picking it up, letting it lie on the floor, whatever. It's going to be fine and wake up those physics rigid bodies and start simulating them so that it can be lifted and grabbed. Now, you may have noticed that we aren't currently able to release the physics handle, so that's going to be your challenge to do that in the release function. So you're going to call release component on that physics handle. That is a function that's available on the physics handle pointer. You're going to check first if we have a get grabbed component. So if you get grabbed component, it returns a pointer to the grabbed component. That pointer will be null if the physics handle isn't currently grabbing anything. So you can use that to check whether we've got anything and only release if we are currently grabbing something. And as a bonus, you can have a go to see if we can set the target again only if we are grabbing something. Pause the video and have a go.
Okay.
Okay, welcome back. So let's go over in to grab a CPP. I'm going to go into the release function and remove the release log. And in here, we're going to put an if statement, and we're going to say if, and now we need to get hold of our physics handle. So we're going to, first of all, do a u physics handle component pointer, which we're going to call the physics handle, and set that equal to get physics handle, like so. Then we're going to say if the physics handle is equal to null pointer, we want to go ahead and return because we're not going to be able to do anything, release anything if we don't have a physics handle at all. Then we want to check whether we are currently holding on to anything with our physics handle. So we say if the physics handle arrow get grabbed component parentheses not equals null pointer, then inside the body of this if statement means we've got something currently grabbed. Well, then we're going to do a physics handle arrow release component, which is going to let it go, as the name would suggest. And one thing I didn't do in the code here, but it's probably worth adding to yours, is that before we release the component, it's worth going ahead and calling get grabbed component and then adding the wake all rigid bodies, just like we did before we grabbed the component, because if we were to grab a component and not move around for a little while, it may also go to sleep, and so releasing it would do nothing. So this is worth adding as it would catch that corner case. And we want to not set the target location in tick if we have got a physics handle that's not currently grabbing anything. So here in our tick components, we're going to put an if statement that's going to be exactly the same. It's going to be saying physics handle arrow get grabbed component not equal to null pointer. Then in the body of the if statement, we're going to
Wait. Yeah, I got physics handle. No pointer.
put the calculation of the target location and the setting target location in that physics handle as well. Let's recompile and try this out. Let's go ahead and hit
Another recompile. Live file. Live compile. Mm. Passwords. Oh. Doesn't compile. Live coding failed. Failure. I'm a failure. U physics handle component. Did I spell that right?
Play. It would.
U physics handle component. Fail. CPU 41. Burp. Hey, yo, that's a new follower, baby. Dead Mortal. How we doing, Dead Mortal? Let me toss that follow back. You earned it. You earned it. There it is. Right back at ya. You the real one. You the realist. What is my error saying? Get Gatab. 4120. Oh, that makes sense. 16.7. I think it's just that. Yeah. Very annoying to have to recompile. Hey, what's up? You're from Reddit. Hell yeah, man. Appreciate that. How's it going? I'm working on some coding. How's the stream going? It's going well. 2 hours, 25 minutes in. It's crazy. That one Reddit post has gotten me more followers today than I have in any other day. So that's huge. I'd call that a success. By end of the stream right now, huge success. But I still got an hour and a half to go. Probably a little bit more than that. Probably a little bit more. What do you stream? Or do you stream, Dead Mortal? I'm just doing some game dev right now. Trying to better myself. It seems like we're build failed. What? Release component. Oh, I'm not familiar with that. Platinum games? I'm gonna have to Google that. I think I understand what trophy hunting is, but platinum pools? Platinum in games. So it's a type of game that just offers trophies? Interesting.
catch that corner case. And we want to not set the target.
Yo, this is supposed to be physics handle. No. Just physics handle. I don't want to recompile right now, though, because it takes 5 ever to recompile.
It may also go to sleep. And if we were to grab a component and not move around for a little while, it may also go to sleep. And so releasing it would do nothing. So this is worth adding as it would catch that corner case. And we want to not set the target location in tick if we have got a physics handle that's not currently grabbing anything. So here in our tick components, we're going to put an if statement that's going to be exactly the same. It's going to be saying physics handle arrow get grabbed component not equal to null pointer. Then in the body of the if statement, we're going to put the calculation of the target location and the setting target location in that physics handle as well. Let's recompile and try this.
Let's recompile. Gonna do it this time. I'm getting some water. I hit you back, Dream Blue. I did. I did it. I did do it. Oh, you talking to the homie in chat? Whoa, this is crazy. People in chat talking to each other. This has never happened before in the history of Twitch. Breaking barriers. Okay, so I can pick this guy up and now release him. Look at this. Swing. Hey, get back here. Swing. Terrible lighting in here, though, yeah? Swing, 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 swing. Ultimately, I want to have to put him on here. And then I'll secret doorway. Open up a secret doorway into another room. After completing the maze upstairs. Also need to figure out why my floors are see-through. What's that about?
Out. Let's go ahead and hit play and try and grab the gargoyle. And then if I let go of the mouse, it drops down to the floor again. So, and it seems to not be affected by whether it's awake or asleep. We seem to be waking it up no matter whether every time we're picking it up, essentially. So that seems to be working exactly as I'd like it to. It's not getting stuck. It's feeling just about right. The only weird thing slightly is when I move into it, you can
what is all this coding stuff for? I am trying to build or learn how to build a video game. So I'm following a Udemy like
it does this weird jittering because actually
this is Unreal Engine.
Colliding with the player. Now we can fix this just a little bit by going to our gargoyle in the details pane, selecting the all category, scrolling down to collision.
Come on, where's the gargy? All collision.
And looking at our custom collision preset.
There is the collision. Physics collision.
And down in the object responses, we'll see a bit more about this later on, there is a pawn object response. This basically says, should I collide with the pawn, or what should my response be to the pawn? Well, I'm going to set it to overlap with the pawn, and that means that if it collides with me, it essentially just ignores it. And then one more thing we have to do is, because this is actually made up of 2 static meshes, they've got their own collision settings. I'm going to go down to the dirt mound, that's the thing underneath the gargoyle. And here I'm actually just going to simplify things, I'm going to make the dirt mound part have no collision. So I'm going to switch to the no collision preset. Then I'm going to go ahead and hit play, grab the gargoyle from the floor, and now you can see when I'm running with it, there isn't any of that weird glitching because it's not trying to collide with the player collision mesh. Great stuff.
So this is one that I'm working on now is going to be like a puzzle type game. Although it's pretty terrible, but hey, it's something. And then I'm also going to learn how to make a first-person shooter. So ultimately, I want to kind of make a first-person shooter. But let's see, this is the Udemy course that I'm following. Unreal Engine 5, C++ developer. So we're currently...
Hello and welcome. In this lecture, we're going to be refactoring our code.
Almost halfway through of this we're well over halfway through of this Crypt Raider game. And then we'll make toon tanks and then a simple shooter, which I'm kind of most excited for, the simple shooter. But honestly, it takes a really long time. Like this is 5 hours and 47 minutes. Like I have spent way more than 5 hours and 47 minutes on this.
To make our grab function smaller and more readable, and we're going to be using out parameters again. This time we're actually going to create a function that takes it as a parameter. Let's dive in and see how to do this.
Let's dive in.
So it's generally best practice for functions to try to fit on a single screen. Now in my case, my screen is very big.
It's really quiet. That's not ideal. So my mic volume is max right now. If I hold it like this, is it better? That's good to know, though. Still not very loud. Good luck, dead mortal. You're a homie. I can increase my desktop audio, but I think that's going to blow your eardrums out.
But we are still learning, so it actually makes sense to have even smaller functions to make things understandable. And I think this grab function has got too long. So I think we can split it out in 2 fairly functional units. The first one is going to be the bit that does the sweep.
Is that too loud now? Dream Blue. Yeah. So I don't actually want... Let's see. What is the ideal mic volume for streaming? Between -12 and -20 decibels. Yep, I'm low. I'm low on that. What if I do this? Yeah, so OBS, can I pull this over here? Yeah. So this is my mic audio right here. Desktop, I definitely don't want this that loud because it's going to drown out my mic. And ideally, what are the cats doing? It should be at negative, like between -20 and -15, I think is what. Nah, dude, the mic's all the way up. Check it out. Yeah, so it's as loud as it can go. I can do some. Let's see, increase mic volume. Oh, that's wrong. Oh, shit. You serious? Oh. Is this better? Is this doing anything? Check it, check. Let's go to like 20. Does this do anything? I think the max is 15 there. Yeah, this is max. Wrong-o. Did you notice any increase? There we go. Oh. Is it too loud now? Slightly louder? Okay. But, like, is it... Alright, cool. But is it going to be... Like, I kind of... If I'm playing video games, like, I might shout a little bit. What happens if I break this red? Boop! Is that, you just destroy your eardrums? Alright, cool. That's good to know. Alright, cool. It just clips. Nice. Hell yeah, bro. I appreciate the assistance on that. Okay. And wait, can you help me with this too?
And does all the calculation of the start and end vectors and outputs the hit result and
is
whether
my
we have hit
mic
or not, the boolean that says whether
getting
we hit.
drowned
And the
out
second
by
bit is
the
inside the if
playback?
statement, which we can probably leave as the job of grabbing, because that's actually to do with grabbing, right? We have to wake the rigid body, we have to grab a component. And that makes sense to be in a function called grab. But this other stuff is a little bit more tangential. It's more of a utility that we need to pull in. So I'd like to challenge you to create that utility, get grabbable in reach. That's what I think it should be called. I think that describes what that lump of code does. So extract all of that sweep code into a new private function. Have a think about what its parameters and its return value should be. Remember, you've got two outputs. So you've got has hit and hit result. So you need to think about trying to use an out parameter to make this work. Now, if you want a little bit of a hint, I'm going to show you what I'm going to put in the header file in just a second. If you don't, you can go and pause the video right now. Otherwise, I'm going to give you the hint. So we're going to go over into grabber.h, and underneath where we've got getPhysicsHandle, we are going to have a Boolean return type to tell us whether something has been, we can get something grabbable. And there's get grabbable in reach. Then we need to give it a parameter, which is going to be an out parameter. So it's going to be a non-constant reference to the f hit result, the reference ampersand, and then we'll call that the out hit result, like so. And then I think this isn't going to change anything in our function, so we can make it const as well. So bonus points if you had already thought of that. So
bonus points.
Pause the video and try and fill out that function in the C++ file.
Bonus points if you've already thought of that.
Okay, welcome back. So I'm going to copy it, go over to the C++. I'm going to put it underneath our getPhysicsHandle component to match the order we've got over in the header file. I'm going to add the U grabber in front. I'm going to indent it correctly. I'm going to add, instead of semicolon, the braces. And then I'm going to move the code that we've got over in grab. So starting at line 53 for me.
Sabanya.
Code, instead of semicolon, the
brackets.
Braces. And then I'm going to move the code that we've got over in grab. So starting at line 53 for me down to 65.
What the heck? No, it's this. Where is this? Oh, there it is. Okay. Yart.
I'm going to cut all of that out, and we'll replace it with something in just a second. I'm going to paste it into get grabbable in reach. And we've got this hit result that we've created. What we can do is we can set that out hit result equal to our hit result that we've got here. We might only want to do that if we've hit, so we can put that if statement has hit like so, and wrap this assignment, the out hit, to the hit result inside the if statement, and then we can go ahead and at the end of the function just return has hit like so. Now, there is an optimization or an improvement that can be made here. Because we are passing by reference into the sweep channel and into grabbable in reach, we don't actually need to create a new hit result in here and then copy it into the hit result. That's just wasting memory. What we can do is we can remove the hit result that we're creating inside get grabbable in reach, and instead we can just use the reference that we've had passed in to pass directly into the sweep single by channel. So it's actually passing this reference 2 functions down into the sweep single by channel, where it will get populated. That removes the need for the if statement, making this function a little bit quicker and easier to read. And in fact, I don't think we even need a variable to store has hit. We can just go ahead and return. It's going to be much cleaner to return the get world sweep channel.
Return value optimization. That's what we like to see.
Results. So we're just kind of passing the results from that through back up into get grabbable in reach, or whoever is calling it. So talking of whoever is calling it, we now need to go up into our grab. We need to create our f hit result somewhere. We have to create it here. So hit result, this is the one we're going to populate. We're going to then create a Boolean variable, which is going to be has hit. We're going to set that equal to get grabbable in reach, and we're going to pass in the hit result by reference that we want populated. And then if we have hit,
Get grabbable in reach, yes. Hit result.
we're going to go ahead and execute the grabbing code. Fantastic stuff. We have moved.
Oh, duh, that's what I just made, right? Here.
Moved something into a function to make this grab function fit on a single screen, and we've again made use of out parameters, this time creating a function for ourselves that
Yeah,
use them
yeah.
in earnest.
Yeah,
I'll see you in the
yeah.
next video. Hello and welcome. In this lecture, we're going to be creating a new component in C++, this trigger box, which will report to us when we step inside the alcove or we place any object in the alcove. You can see we're getting a little blueprint message up in the top left-hand corner. And to do that, we're going to have to understand how overlaps and blocking and different collision responses behave in Unreal. Let's dive in and find out.
Now,
we've already become familiar with how trace channels work. We know that you can have trace responses on the different objects in our scene, such as this shrub here. You can see that it has an ignore response to weapon traces, but it does block visibility traces. Then there's this bulletproof glass example. It blocks weapons but allows visibility through, and a brick wall which blocks both. So you can see how this system works with trace channels. Now, what happens if we're trying to decide which objects can overlap with each other, which ones pass through, which ones block each other? That can get a little bit more complicated. We saw this already when we tried to get the gargoyle to overlap with our pawn. Now, this is how it works. Essentially, we use these object types. Each object can belong to, can be a particular object type, and this is different to the kind of type system in C++. These are collision types. So you might have object A and object B, and in their settings, if we go and have a look at the settings on our gargoyle, for example, you can see that they have their own object type. This one is a world static object. But then further down, they have their responses to other types of object as well. So you can see that this object will block other world statics, it will block other world dynamics, it will overlap the pawn types, it will block physics bodies, and pretty much block every other type. And obviously, the pawn itself, if we go and find our BP player and look in its capsule component, look at the details and scroll on down to where we've got a collision preset. If we can expand out the pawn collision preset, we can't edit it, but we can see what it's doing. And
slow down, pawn. Here we go. Yeah. Right.
And you can see that it has its own response to world static. So its response to the world static would be to block it. So we've actually got two different options here. The pawn is saying, I block world statics, but the gargoyle is saying I overlap pawns. So what should happen? Well, this is where this table comes in. I've got a link to this blog post if you want to read it in full in the lecture resources. So you can see that it takes the least blocking interaction between the two. So if object A was the pawn and it's saying, hey, I should block that gargoyle, but the gargoyle's object B and it's saying, hey, I should overlap that pawn. So it's going to take the least blocking of those two and it's going to overlap. So it does mean that if you want two things to block each other, they both need to agree that that's what they want to do. So let's look at another example here. We've got the player, which is of object type pawn, and its object response to other pawns is to block them, and world static objects is to block them. The brick wall is a world static object. It can block pawns and block world static. So these two would agree with each other. Now the shrub is also world static, but it overlaps pawns. This is very much like our gargoyle, but it blocks world statics. So if you go down and have a look at what would happen, is the pawn would try and travel through the bush, and it could, because it takes the least blocking option, which is overlap, and it generates an overlap event, which we can hook into in code or blueprint, whereas it won't be able to pass through the brick wall, and it generates a hit event, again, something that we can hook onto in Blueprint or C++. So why do I go into all of this depth? Because what I want to do is put an object that is basically invisible inside this wall that allows us to put the gargoyle in here, and we get an event when that happens. So the gargoyle will prop up an event and say, hey, I've got something overlapping with me. So why is all of this important? Because I want to put an object that's invisible, but will overlap with the gargoyle and let us know about that fact. We can then query it from C++, or we can get events in Blueprint either way. And the way we're going to do this is, first of all, create a blueprint from this dungeon wall. So I'm going to click the blueprint button in the details pane, create a new subclass, and I'm going to name it.
Hey, chill, dog, chill.
We can get events.
I want wall decorative. That's the one.
In Blueprint either way. And the way we're going to do this is, first of all, create a blueprint from this dungeon wall. So I'm going to click the blueprint button in the details pane, create a new subclass, and I'm going to name it BP_secret wall. And we're going to hit select to create it and dock it to our main window. And it's got a mover on it. What I also want to add in here is essentially a component which is called a box collision.
It's got a mover on it. Come on, back that ass up. Let's see what's.
Hit select to create it and dock it. Click the blueprint button in the details pane, create a new subclass, and I'm going to name it BP_secret wall. And we're going to hit select to create it and dock it to our main window. And it's got a mover on it. What I also want to add in here is essentially a component which is called a box collision. So if we click on a box collision, you can see it's completely invisible. It just gives you some box extents, which we can change. We can make them larger so that anywhere we place the gargoyle in this box, it's going to accept it. And we can see that it has got collision options down here. We've got an overlap all dynamic as the default, as the default preset. But if we hit custom, you can see we can change the object types and we can change how it responds to different things in here. And I think most importantly, as you can see, it's set up to overlap with most object types, which means that even if they're not set to overlap with world dynamic, it's going to overlap. It's not going to block anything. It's going to let us position the gargoyle in here. So I'm going to go and delete that component from the scene, because what I want to do is create a new component in C++ based off of that box collision. Now, I just want to show you that with this box, if we set it back to the default preset it was on, which was overlap.
Collision. Collision presets, overlap, all dynamic.
All dynamic, I believe. And we check, or as is already checked actually, generate overlap events is already checked. Then we can go over into our event graph and we can right click in here and look for overlap. And right at the top, you can see an add on component begin overlap for the box. So if we click that, and actually let's rename the box.
Holy cannoli. Right, so, okay.
Component to trigger area, like so. And basically, if we overlap with the trigger area, we're going to get a list of properties of the thing that's overlapping with us. So we could take the actor that's overlapping, we could get its name. So get display name is the name of the node. And then we could take that and print the result string and hook that up to the execution pin. and we can go ahead and hit play. And if we
Oh no. Get over here, little gargoyle. Ding, ding, ding. I got it. Get on that shelf, boy. Come on, get on the shelf. There it is. There it is. Didn't do anything.
walk up to the area, you can see that it's saying the BP player is the thing overlapping it. Now, I can't see that area because it's so dark, so I'm just going to go to the secret wall again, the BP, and I'm going to add in a spotlight component, which I'm going to place in this little alcove, rotating it face down and illuminating the space.
The secret wall, because it's not the secret wall. Homie. Secret wall? It is the secret wall. Now I'm confused. Spotlight. Bow, 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 bow. Sexy. Sexy. Oh. Creepy secret wall. Oh, it is working. Okay, cool. Yes. Yes. Toss it. Oh, no. Toss it up. Hey. Get back here. Get back here. Yes. Look at it. Why isn't... It doesn't have a name? If you roll char 0. It doesn't have a name. Why doesn't this have a name? SM statue hooded metal. Squeeze me.
Where we want the object. Now in the scene we can see it very clearly. So let's go ahead and hit play. We can walk up to that alcove. If we overlap it, it says there's the BP player overlapping. And we can go and grab our gargoyle from this cell using our newly minted grabber. And we can take that gargoyle and place it in this area. However, it doesn't seem to be generating any overlap events. And that's because just like there's two parties to the collision, there's also two parties to generating overlap events. So just because we have it enabled on that box component doesn't mean that the gargoyle moving into it is actually going to alert us to any overlap events. So what we have to do is we have to go to the gargoyle and check its generate overlap events as well. So then...
Yes. Yes. Get over here, gargoyle. Well, your name's not gargoyle. We're about to find out what your name is. Shibloink. Mother. Excuse me, that's not working.
The overlap events should happen. Let's go and pick up the gargoyle, take him over to the alcove, and stick him in. And now we are getting an event coming up.
Yo. Fucking not cool, man. It was not Crypt Wall. What is your name? Oh, some statue hooded metal. Collision simulation generates hit events. Overlap events, I think is what it was. Control S, that. SM statue, hooded metal. Let's go, baby. I want to be a cowboy, baby. I want to be a cowboy, baby. I want to be a cowboy, baby.
When that happens, the gargoyle statue is indeed being registered. Now, I don't want to be using blueprint events in this particular case, so what I want to do is take our trigger area component.
Where are you seeing? Oh, here it is, trigger. Yeah.
And actually turn that into a C++ component that can evaluate whether it's got the gargoyle statue it wants or not already in it. The way we're going to do this is we're going to go to the add components, create a new C++ component, and as the parent class, instead of choosing act component or scene component, we're going to go to all classes and we're going to search for the box component instead. And you can see the shape components, box components, the one we want, and we can go ahead and hit next. So I'd like to challenge you to create this.
Whoa. Shape component, box component. Yeah.
One we want, and we can go ahead and hit next. So I'd like to challenge you to create this component now that I've shown you how to set the parent class. So you're going to name it trigger components, and you're going to have to copy some things from the other components we've created because it's not set up in the same way, seeing as we're deriving from a different parent. You're going to have to copy the U class line. That whole line is basically empty on the trigger component as you'll create it. So copy that from either your grabber or your mover, and otherwise you won't be able to add your components into your blueprint. So then you should use this new trigger component to replace our current box component and print something from begin play. Again, begin play won't be settled up automatically for you, so you're going to have to copy from the header file and C++ file of our other components in order to set it up. Pause the video and have a go. Okay, welcome back. So I'm going to call it the trigger component, all one word, and hit create class. So as predicted, our U class line is got nothing inside.
I'm looking at my phone.
Call it the trigger component, all one word, and hit create class. So I call it the
create class. Should open up in here. Yes, so far so good.
All one word and hit create class. So as predicted, our U class line is got nothing inside the parentheses. And if we go and have a look at our editor and go to the BP secret wall, try to add this component and search for trigger, you can see nothing comes up. And the reason for this is if we went over to our grabber.h and had a look at its U class line, you can see that there's a bit in here that says blueprint spawnable component. So crucially, we need to copy this. It also has a class group. We might as well copy the whole thing because this allows us to create this component in blueprint. So we can go and paste this as the U class line for the trigger component. And then the other thing, if we go to grabber, you can see it's got begin play. It's within a protected section, and we can just
begin play.
Copy the definition of that begin play function, copy it over into our trigger component and put it as it was in the grabber. It over, and we can just copy the definition of that begin play function, copy it over into our trigger component and put it as it was in the grabber, just underneath the generated body. Then we can go into our grabber CPP and see how begin play was defined in here. You can see that it has this call to super begin play. That is actually important. So we're going to copy that, go over into a trigger component CPP, and we're going to change the U grabber : to U trigger component begin play.
Why is the U? Is that unreal?
And then in here we can put in our ulog, and we're just going to write a simple message such as trigger component alive. We'll go ahead and compile. This may take a little while, seeing as we've made some fairly significant changes to our header file. And once that's done, we can go into our...
Oh, I gotta freaking compile. Let's just make sure all this is correct. U class, yeah. U grabber public. I think I didn't do that right.
Print. So we can go and paste this.
Trigger.
This allows us to create this component in Blueprint. So we can go and paste this as the uClass line for the trigger component. And then the other thing, if we go to Grabber, you can see it's got begin play. It's within a protected section, and we can just copy the definition of that begin play function, copy it over into our trigger component, and put it as it was in the Grabber, just underneath the generated body. Then we can go into our Grabber CPP and see how begin play was defined in here. You can see that it has this call to super begin play. That is actually important. So we're going to copy that, go over into a trigger component CPP, and we're going to change the uGrabber : to uTrigger component begin play. And then in here, we can put in our ulog, and we're just going to write a simple message such as trigger component alive.
Live code this. Well, live code this. Oh. Ah, shoot. Oh, that's a follow. The Senpio. Hell yeah, dog. What up, the Senpio? How you living? How you living? The Senpio? Is that what it is? Alright, it worked. We successfully linked the patch. I'm not quite sure what I'm supposed to do right now. That was in here. Secret wall, yes, very good, very good. That seems to be working appropriately.
We'll go ahead and compile. This may take a little while, seeing as we've made some fairly significant changes to our header file. And once that's done, we can go into our BP secret wall.
Oh, that's what I didn't do.
Go to add and search for trigger. And in here,
trigger.
you can see we've got that trigger component. We can now add that in. We can remove our trigger area that we've set up previously. Just go ahead and delete that and check. Yeah, we want to delete it. It's going to basically invalidate this event that we created. And we can check that the collisions are set up as we want on the trigger.
Wait a tick. We'll delete the trigger area. Yeah, that's fine. That's fine.
Trigger. If we go and have a look, yeah, it's set to overlap all.
Trigger. Oh shit! How do I open the details? View, debug, window, details. There it is. There it is. Generate overlap events. Yeah.
Dynamic and to generate overlap events. And finally, what we need to replace is this event here, where we're going to select our trigger, right click, and go to unfurl the add event for trigger, collision.
Delete. What? Where did you see?
Event here, where we're going to select our trigger, right click, and go to unfurl the add event for trigger, collision, and add on.
Ah, interesting. Add on component begin overlap. Yeah, doggy.
Component begin overlap. That's what we were using before. Hook up the actor pin and hook up the execution pin at 2. Head over to the dungeon level, go and pick up the gargoyle, try and stick it in the alcove, and we notice that's not working. So now we've got that trigger set up. Let's go to the viewport, and you can see that actually the trigger hasn't been made big enough.
Oh my goodness. Lord Jesus, there's a fire. Shibloink. I mean, it's still working.
Positioned it correctly, so let's go and position it in the center of the alcove, and let's increase the box extent properties so that we catch whatever we've put inside this alcove area. Doesn't matter if it is a little bit bigger and gives us a safety margin. Then we can go into the dungeon, hit play, and then step into the alcove, and sure enough, it detects that the BP player has walked into that alcove. Great stuff. In this lecture, we've learned all about object types and object type responses, and we've used that to set up this trigger component.
Hell yeah, dog. Question is, do I keep chugging along on this? I kind of don't think so. Methinks I can... Oh, methinks I can toss the guy. Where'd he go? Can I open this door, please? Interact. Alright, yeah, I'm gonna save here. And let's play some Minecraft, baby.